Polycet 2017 World Question Paper Physics Explanation Part 2 video. In the previous video, we explained from 61 to 75. Now from 75 to 90. So now 76th bit, student. When a light travels from rarer medium to denser medium, so it bends away from the normal or bends towards the normal or goes along the straight line or moves in parabolic path. So light ray is traveling from rarer medium into denser medium. So now we can see this one, 76th bit. For example, it is the interface which is separating both rarer medium and denser medium, and it is the normal. It is a rarer medium, it is a denser medium, and this is a light ray, incident ray. It is angle of incidence. But you know, when it enters the denser medium, it bends towards the normal. So it is a refracted ray, it is incident ray, and this is angle of refraction. Why it is a bending towards a normal? Speed decreases. When it travels from rarer medium to denser medium, speed decreases. So it is bending towards normal. So now you can see the option. It bends towards the normal. Denser to rarer means it bends away from normal. Next to 77, students. 77, you can see. Pick out the correct answer from the following. Focal length of the lens depends surrounding medium. This is right. Focal length of the lens changes with object distance. This is wrong. So only option A is true. This is. The size of the image formed by a convex lens is same as that of object when the object is placed. But in the ray diagram, you can observe this. When the object is placed at the center of curvature on the principal axis of a convex lens, we can get same size real and inverted image by the convex lens. So object is placed at the center of curvature. Object is placed at the center of curvature. Next, 79, students. The lens which is thin at the middle on both sides and thicker at the edges. So now you can see this one in the form of diagram, which is thinner. So at the edge, these two are edges. At the edges it is thicker, in the middle it is thinner, and here it is thicker. So this lens is biconcave lens. So you can see the option. The lens which is thin at the middle, both sides, and thicker at the edges. So this is biconcave lens. Thicker at the middle means biconvex lens. Thin at the middle means biconcave lens. Next, 80, students. Question number 80. If 40 cm each and object distance, image distance respectively for a convex lens, then focal length. So question number 80, students. It is a convex lens symbol, and this is a principal axis, and it is optic center. Focal point F1, center of curvature C1, focal point F2, center of curvature C2, and here object is placed. So from here to here it is radius, and also here to here it is object distance, and here to here it is radius R1, and now here image is formed at the center of curvature. It is a C1. Here image is formed. So this is also equal to image distance, but image distance and object distance both are given same. 40 centimeter. So when the object and image distance are same means object must be placed at the center of curvature, then image is also formed at the center of curvature. So object distance equal to image, object distance denoted by u, image distance denoted by v, which is also equal to radius, that is in the given problem 40 centimeter. So it means that indirectly radius r is given 40 centimeter. Then we want to find focal length. We know the relation between radius and focal length. Focal length is equals to half of the radius, that is 40 by 2, 20 centimeter. So you can see the option 20 centimeter. Function of the rods of the retina. So generally retina is made of receptors called rods and cones. The retina in the human eye can act as a screen on which image is formed. So this retina is made of 120 million receptors. Some are in the rod shape, some are in the cone shape. Function of the rods is identify the intensity of light. Function of the cones is identify the color of light. Next, 82 students. Maximum and minimum focal length of eye lens. Maximum focal length is 2.5 centimeter. Minimum focal length of eye lens is 2.27 centimeter. These are fixed. So with the help of ciliary muscles, so the focal length of eye lens can be increased and decreased. Can be increased to maximum 2.5 centimeter and can be decreased to minimum 2.27. Next, a doctor advised to use 4D lens, then focal length of the lens. So power of the lens is given, students, 81, 83. Power of the lens is 4 diopters. 4 diopters given. Then we want to find focal length. We know power is equals to 100 by f. This implies f is equals to 100 by p. And power value is there 100 by 4. 4 ones, 425. But in this formula f is taken as a centimeter. So f is 25 centimeters. So you can identify the option 25 centimeter. Next to so from 84 onwards, students, from electromagnetism chapter, this is also from light chapter. With the increase in the angle of incidence of the light ray on a prism, angle of deviation. So in the question answer concerned to this topic, from the graph using refractive index of the prism, so you can identify initially angle of deviation decreases, then it increases. So while reading the question answer related to this one in the 10th class of physics, so you can identify this line, first decreases then increases. Next one, students, the scientific work of C.V. Raman is scattering of light. Scattering of light. So remaining 86 to 90. So from 86 to 90 physics bits are taken from electromagnetism chapter, students. So these bits can be explained again after discussing this chapter, so in our channel.